Okay, so today's lesson 9.3, histograms and box plots. Essential question, how can you interpret and compare data sets using data displays? And the pages that I'm going to cover today are out of your consumable, pages 401, 405, and 406. We are currently on page 401. So we want to first understand histograms. A histogram is a bar graph that is used to display the frequency of data divided into equal intervals. The bars must be of equal width and should not overlap, but they should touch. The heights of the bars indicate the frequency of data values within each interval. We're going to look at the histogram of scores on a math test. Which axis indicates the frequency? So we're looking at this graph over here, and our frequency is running vertically. So that's our vertical axis. What does the horizontal axis indicate? Down here, we're running horizontally that way. A good way to remember which direction is horizontal is I usually think of the word horizon. Like if you're watching the sunset and you're looking at the horizon, that runs from left to right. So the horizontal axis shows test scores. How is the horizontal axis organized? It is organized in groups of, well, if we look at the horizontal axis, the way these numbers range, each of the bars, groups of 10. How many had scores in the interval of 60 to 69? So we're going to look at this first right here, and you can see that it lines up. The top of the bar lines up right here. That's a very squiggly line. It lines up right here, okay, which would be at 3. So we're going to put a 3 right here. How many had scores in the interval of 70 to 79? Switch colors. That's our next interval. Okay, you can see it lines up right here, which would be at 9. How many had scores in the interval of 80 to 89? That's this bar right there. And that's lining up right at 12. How many had scores in the interval of 90 to 99? That's our last bar. And going over, you can see that it's lined up right at 7. So what statistical information can you tell about a data set by looking at a histogram? And what statistical information cannot be determined by looking at a histogram? Well, it is easy to see the general shape and distribution of the data. We can tell that statistical information by looking at a histogram. But it is difficult to know the actual data values. So even though we have a range represented in each bar, we're not quite sure what those exact values are. Number 2, how many test scores were collected and how do you know? Well, All we have to do for that is look at each interval and determine the number of test scores in each. So we had 3, 9, 12, and 7. If we add those numbers up, we get 31. So 31 test scores were collected in all. Okay, moving on to the next page. We're not going to do number 5. We're going to look at constructing box plots. A box plot can be used to show how the values in a data set are distributed. You need 5 values to make a box plot. The minimum or least value, first quartile, median, third quartile, and maximum or the greatest value are those 5 values that you're going to need. So for example 3, they use the data to make a box plot. Our data is the numbers of runs scored by a softball team in 20 games. So we have all these data values here. This is all of our data. Now what we want to do is order our data from least to greatest. So that's what they did here. They reordered all these numbers, but they put them in order. A good way to do that is as you write them down to cross them off. Okay, so if I wrote a 2 here, I would cross that 2 off there so I don't accidentally use it again. Then I cross off the 3s each time I write one and continue to do this so that way I don't accidentally repeat or not use enough of the data values. So once we've ordered our data from least to greatest, and this is kind of like your first step, then you want to identify the 5 needed values. This would be our second step. Those values are the minimum. Okay, so let's use a different colored highlighter here. We have the minimum, which is right here. It's the smallest value. It's 2. We need the first quartile. That's represented as Q sub 1. Happens to be 4 in this case. Our median. Middle value. When there's 2 in the middle, you take the mean or the average of those 2 numbers. 7 plus 8 is 15, and 15 divided by 2 is 7 5/10. And we have our third quartile, which is from this data right here. It's 10. And our maximum is the last important number we need, which is the biggest value, the greatest value. And now using these 5 values, they're going to create the box plot below. So now that you've identified your 5 values that you need to draw a number line, okay, a number line, and plot a point above each of the 5 needed values. So that's where these values came from. Let's go back and use the same color. So there's our minimum for the first quartile. We used 4. That's that point. The median we determined was 7.5. The third quartile was 10. And the maximum value was 14. Once you have those plotted, then you're going to draw a box. So this is kind of like the 4th step. Draw a box whose ends go through the first and third quartiles. That's what this box is right here. It's going through the first and the third quartiles. And you need a vertical line segment through the median. Okay, so then you have to have that piece going up and down right there. And a horizontal line segment from the box to minimum and maximum. So you gotta put in all the boxes and lines. That's the last step. There's no arrows on there, okay? They stop at the actual points. All right, so we're gonna do an example, and that'll complete our notes. And this is kind of a structured example, so we're just gonna be able to fill in the pieces as we go. So our data set is listed. 13, 14, 18, 13, 12, 17, 15, 12, 13, 19, 11, 14, 14, 18, 22, and 23. Remember, first step is to order the data from least to greatest. And we're going to use that method where we cross off the numbers as we write them in. Let's use black for this. Okay, so 11 looks like it's my smallest one. So I'm going to put in 11 here. Sorry for the terrible 11. We have two 12s, right? And then it looks like we have 13 as the next number. There's another 13 and another 13. And then we go to 14. And it looks like there's two more 14s. A 15, a 17, 18, 18 again, a 19, 22, and then our biggest value is 23. All right, so we got our data ordered from least to greatest. That's the first step. And then next thing we're going to do is identify what those 5 values are that we need. Okay, so we got to get the minimum, the first quartile, the median, the third quartile, and the maximum. So I'm just going to use colored pen this time. The minimum is your smallest value, so that's 11. And your maximum is your largest value, that's 23. The median is right in the middle. It looks like we have 14. And that box is large because there's two values of 14 in the middle. So if I'm taking the median, it's 14. And even if they were different numbers or the same number, you're still taking the average of the two that are in the middle, if there are two in the middle. Same thing for our first and third quartiles. Let's go ahead and switch our colors here. 13 and 13 are the two numbers, so the quartile is 13. And 18 and 18 would give me 18 for the third quartile. Okay, so we are going to then move on to step 3, which is to draw our number line and plot those points. We want to plot the points above the number line. They don't go directly on it for each of these 5 values. So let's start with 11. It's going to go right here. And I'm going to put I'll just keep switching my colors. Okay, so 13 I'm going to do in blue. So it's going to go here. And then 14 will be right here. 18 and 23. Awesome. Okay, now we're moving on. We're going to draw in the boxes and the lines. So the box has to go through the first and third quartiles. That's the blue and the green. All right, so I'm going to switch over to black. And I'm going to draw a box as best as I can. Please don't make fun of my box. It's terrible. And draw a vertical line, okay, going up and down through the median, which means it passes through right here, and then the horizontal lines will go right here, right there. And that's how you create your box plot. All right, so we're just going to look at the 2 reflection questions and then we'll be all done. So number 6, the lines that extend from the box in a box plot are sometimes called whiskers. All right, they kind of look like whiskers. So if you think about like a cat face, I don't know what I'm doing. Okay, here's my cat face. Because whiskers go like this, they come out. So that's why those 2 little lines are like whiskers. Again, that's a terrible cat. Okay. What part, lower, middle, or upper, and about what percent of the data does the box represent? The box is right in the middle. okay? And it's actually representing 50% of the data, okay? So the box represents 50% of the data. The left whisker represents the lower 25% of the data. The right whisker represents the upper 25% of the data. And our last question, number 7, which measures of spread can be determined from the box plot, and how are they found? Calculate each measure. So what we can figure out is the range. Okay, that's where you take your greatest value and your least value and you subtract them. So we had 23 and 11, the minimum and the maximum. You subtract those, you get 12. And then we can also figure out the interquartile range. That's where you take your two quartiles, quartile 1 and quartile 3. In this case, 18 and 13, and we subtract them. So the interquartile range is 5.